see that Holly Cole is joining us. Hello, Holly. Um, my sister is actually right now moving to New Mexico, where you're at. She will be in Las Cruces.
Oh, very
I will
nice.
be,
The southern end of the state.
uh, and I will be visiting her from November to about February or March.
Much more pleasant time to visit. It's beautiful.
Very nice. Well, I'm going to get us going here because I know we've got a busy and a lengthy TMN Tuesday event today. I've got the recording going for folks that are not able to watch us live. But welcome to our TMN Tuesday July event. This is our monthly webinar series where we highlight different naturalist topics or events that our master naturalist volunteers and general members of the public are welcome to learn alongside with us. As always, we like to get started with a little bit of a tech check to make sure that all of our members and our audience is able to participate in today's webinar. If this is your first TMN Tuesday, don't worry, you cannot unmute and you cannot show your video. That is on purpose. We regularly have hundreds and up to thousands of participants, so we want to make sure that we're giving our speakers and all of our speakers today that due attention for their content today. So if you're getting to this point in the webinar and you're going, oh no, I can't hear, I'm seeing she's moving the slides, you're seeing my mouth, you're not able to hear me tell you to check your audio, but hopefully you can read this screen and check your audio by making sure that everything's plugged in. You're not hearing me tell you that to plug those in, but hopefully you're reading this and getting all of your audio all set up. But if you are able to hear and you do want to participate in today's webinar, we're going to use the chat. Our chat function today is open to communicating with everybody. All of our panelists and our speakers are able to communicate with that and answer your questions. If there are too many questions, we'll try to hold those to the end. We do have a Q&A time on our agenda today at the end of the webinar to try to get some of those questions answered, but I imagine as many of our master naturalists have lots of questions, that we'll have some that just won't get answered today. But help us as moderators by using full and clear sentences, avoiding acronyms, and the best spelling possible so that I can make sure that I can get that question that you're intending to be asked to our speakers and our hosts today. And please keep all chat on topic and professional as well. And I'm going fast through this intro because we have a little bit of intro content that's different from today's event that I want to make sure that we get through quickly today. Last but not least, our WebEx help call center, as always, is available if you still experience issues. Our general TMN Tuesday webinar etiquette for all of our presentations. Attendees are not able to unmute or share their videos, but that's where we have our chat for professional and on-topic discussion only. This WebEx will actually run a little over an hour today, so our master naturalist, if you are logging that, will log the full length of the time of the webinar as we wrap it up. It's about an hour and a half is what we're looking at, I'd imagine, today. Okay. Oh, and then last but not least, please help us by supporting our events, by taking our surveys throughout the event today. Go ahead. All right, so sharing a little bit of information about the Master Naturalist program. If you are new here, if you're not a part of our Master Naturalist program, welcome. We'd love you to be a member of our volunteer corps that is out there as a representative, our two supporting state agencies, helping to conserve, educate, and outreach to the public about these conservation issues. The first place to get started, if you are not a master naturalist, is to find your local chapter. We have 49 chapters. This map is outdated as of a month ago when we added a new chapter into our ranks. So we're excited to have a new chapter on board in the Uvalde area. But find your local chapter and then get started with their training. Okay, and I'm sorry I'm talking fast here. I'm trying to get through our intro slides so that we can make sure that we give our speakers all the time possible to talk about the eclipse and eclipse safety today. But as part of our program at the state level, we host these monthly webinars, we also host an annual meeting as well. So I'm going to give a little bit of information for those that are not familiar with our program, a little bit of information about these webinars and these statewide events. Our TMN Tuesday events happen on the second Tuesday of each month at noon, typically are about an hour, sometimes can go a little long as it will today, and they are always free and available to the public. You can see our upcoming one in August will be August 8th, and then in September 12th. But then in October, we have an exciting event at our state level. We have our annual meeting. Our Master Naturalist annual meeting is open and available to all members of our program and the general public. So if you're not a Master Naturalist yet and you want to have a weekend hanging out with the cool kids, please come down to McAllen in October. It is an event not to miss for the naturalist in Texas. For our Master Naturalists, you've probably seen this on our website, and hopefully you're getting our emails about the upcoming annual meeting, but we did just release our agenda, our full event agenda. I have a skeleton agenda here just to share some of the highlights. We are beginning our event on Thursday, earlier than normal, and we're running a little bit longer than normal. We're ending short on Sunday this year. And with it being in the Valley, please join us for an elongated travel holiday destination annual meeting. We've got field sessions scheduled all the way from Wednesday through Sunday, and there's so much more to see in the Rio Grande Valley of Texas that it's worth taking a few extra days for yourself. And you will notice that one of the highlights on the event agenda is our annual solar eclipse event and our offsite day. I'll talk a little bit about that in a second. During our Thursday and Friday sessions at the annual meeting, we have concurrent technical sessions with over 100 speakers coming to talk about a variety of different topics. I did want to share just a little sneak preview of some of the topics that we have on that agenda as well. We just launched our registration pricing for this event. We haven't launched registration yet. Registration will open the first week of August, but we do have our pricing available as well so that you can start to make your plans for registration when we open that in August. And lodging. Don't forget to find a place to put your head to sleep at night during the conference, as we're going to have long days and lots of, you'll need your rest each night. But we've got 5 hotels blocked for the Master Naturalist Conference. Room rates range from $100 to $139, and the links are on our website that I'll drop in the chat here in just a second. Some of our hotels are starting to book up quickly, so if you're having issues and you want a specific hotel, please call them. We have found that has been the easiest way to make sure that folks are getting the right rooms and the right block accommodations. And then how do you get down to the McAllen? We are working on putting together a discussion board for our attendees, for Master Naturalists, for folks that are interested in joining us at our conference to find carpool and caravan options. This will be a self-serve discussion board, but this is an opportunity for our folks to be able to share rides and get down to the Valley. Okay, last but not least, as I'm wrapping up about the annual meeting, something that leads into today's TMN Tuesday presentation. When we scheduled the annual meeting, we knew we had to blow it out of the park, and so we went with the solar event. We had the whole solar system line up so that the weekend of the annual meeting, we had an annular solar eclipse. You're welcome. We did that. No, we didn't. But as part of the solar eclipse happening during the annual meeting, we knew we wanted to take our Master Naturalists outside. We wanted to experience this event with you guys, and we wanted to do it in a place that is just an amazing piece of property. It's an amazing area, and it's going to let us to really have a full viewing of the annular solar eclipse. It's going to let us learn with boots on the ground in the thorn scrub brush, and experience a lot of what makes a classic South Texas thorn scrub a great area. So we're going to take the entire conference down for the day of Saturday, October 14th, out to the El Sal's Ranch. We're arranging transportation for the whole conference to go out there for that day, from 8 a.m. to 4:30 p.m. Bring your gear, bring with us. We're going to have field stations in the afternoon. We'll provide lunch. We'll have restrooms. We'll have water as well. We're also going to have an eclipse viewing with speakers and safety gear to be able to watch that eclipse viewing safely. And I think Dorian's going to talk about that and what that gear includes during her presentation. So I wanted to give y'all just a little bit of a sneak peek into the eclipse field day at the ELSALS. It's going to be awesome. I cannot wait to get down there with you guys. Okay. Again, sorry, I needed to get through that introduction and tell y'all about what's leading up to today's TMN Tuesday and why we asked these speakers to join us. We do have this astronomical event occurring in October of this year, but we also have another astronomical event happening in April of next year. And we want our master naturalists, our naturalist volunteers, to be prepared with resources, tools, information, safety information for that event. But then also, as the detail data-oriented naturalist that you are, we wanted you to have the tools to participate in community science programs like GLOBE and Soundscapes, to participate in those events as scientists, as data collectors. And so that's what we're going to talk about today. We do have quite a few speakers with us today, but again, we wanted to give you that full scale effect of all the way from what is an annular solar eclipse that Dorian's going to share and how to view that safely with a safety training, but then how to take measurements and how to participate in that event and the April event through the GLOBE tool that Kristen's going to share with us, and the Eclipse Soundscape project that Trey is going to share with us as well. So full event agenda. I have wasted 12 minutes of it, but I'm going to turn it over to Dorian because I want y'all to be able to see all of what we are going to experience in October. And I'm going to put this slide back up at the end, Dorian, but this is, and Trey, this is going to follow your presentation, but we do have a survey that we'll share at the end of today's presentation. So, Dorian, I'm going to kick it over to you. All right, Dorian, you should be able to share a little bit about yourself and your program, and then share about the eclipse. And don't forget to unmute as you go into it. Oh,
all right. How are we doing here? Are we able to? It's always such an interesting thing. I was a teacher teaching in person for so many years, and now relying on technology is always it's a mixed bag. But right now, just let me know. Are you able to see my slides in the
yes, ma'am.
way? All right, fantastic. So I am so excited to be here today for a number of different reasons. One is because I have had the honor and the privilege of being able to experience the 2017 solar eclipse. I live in Maryland, so I was actually in Maryland, and this picture here, I'm teaching some kids at my local library in Maryland about the eclipse. Even though they weren't in the path of the eclipse, it still was something that was happening around them, and I wanted them and their parents to get an understanding of what was going on. But what an exciting thing you have ahead of you in Texas, because you are going to be experiencing not just one, but two of these absolutely incredible events. So I wanted to share with you, before I jump into the rest of my talk, I want to start off by kind of having you look through the lens of just how exciting it is to be at one of these events, and also a few of the ways that you can reach out to people in your community and get them prepared for the fact that Texas is right there in X marks the spot and going to be able to view not just one, but two upcoming eclipses. On the right-hand side is me sharing information about the. On the left was ever so much fun. I was at a minor league ball game in Oregon. We were right under the path of totality, and it was phenomenal. And there I am with those little folks. This was over in Corvallis, Oregon, working with kids in a library and their parents and telling them about what was going to be happening and ensuring that they understood about the importance of safety. Here I am with the little people in Maryland, but telling them about the sun, letting them still use these solar glasses and getting a chance to see something that's very surprising. And that is when you are able to look at the sun, it's actually very small, which is rather surprising when you look at it through our solar glasses. Here I am with my husband. We happened to, while we were up there in Oregon, be able to get over to a brewery that was focused on the upcoming eclipse. And then there's my husband with my cousin, and we had brought with us, and I will be bringing this to Texas, a solar scope where you're able to look at the sun. And generally we use this before and after the eclipse, kind of while we're waiting, because that's a lot of fun. And then here is one of my own personal pictures of the solar eclipse while it was happening. So I am going to now tell you a little bit about what eclipses are, the difference between an annular eclipse and a solar eclipse, and explain why it is so exciting that this is taking place in Texas. So here we see this map of the United States, and the dark paths that are going across the continent are showing where observers will need to be to see the ring of fire when the moon blocks out all but the outer edge of the sun during the annular eclipse, and the ghostly white outer atmosphere that I showed you in my previous picture, where you're able to see the sun during the total eclipse, when the moon totally blocks the sun's disk. Outside these paths here, it shows how much of the eclipse or how much of the sun is going to be eclipsed by the moon. And this is a new eclipse map by NASA. It is easily available to all of you. And when you watch this video that we have about this map, it goes into more detail and explains what these different circles mean. I did create or take one of these pictures here to go closer into Texas. The eclipse path we're seeing on the left, running from the top left to the bottom right, that is our annular eclipse. And it's made kind of in a different shape. It's basically made in that shape to differentiate between what this annular and total eclipse be like. And I'll explain to you that difference in a few more slides. But what we're seeing here with these different ovals is they're showing us the shape of the moon shadow cast on the Earth's surface. And that also will give us the times at which you're going to be able to see these eclipse events happen. So what I want to do here today is a little bit of information on an annular versus a total solar eclipse, tell you a little bit about some of the research that NASA is doing with the eclipse, and then talk with you a bit about the Texas Master Naturalist's role in citizen science, and then finish up by talking about the safety. So what is a solar eclipse? Here we've got a short video.
A solar eclipse occurs when the moon moves between the Earth and the sun, blocks the sun's light, and casts a shadow on the Earth. When the moon completely covers the bright disk of the sun, that's a total solar eclipse, and it happens roughly every year and a half somewhere on Earth. A partial solar eclipse is more common, happening at least twice a year. A lunar eclipse, on the other hand, is where the moon moves behind the Earth, so it's now the Earth blocking the sun's light on the moon, creating a shadow on it with a red tint. The easy way to remember the difference is to remember what gets darker. With the solar eclipse, the sun gets darker, and during a lunar eclipse, the moon does. A solar eclipse is a rare event that not many get to see, because the moon's shadow is relatively small. This limits the locations on Earth that get to see it. You have to be on the sunny side of the planet, and you have to be in the path of the moon's shadow. So, if you find your area in the path of totality one year, you've hit the jackpot, because on average, that same spot on Earth will only get to see a 75 years. During a solar eclipse, the moon casts a shadow with two parts, the umbra and penumbra. The moon's umbra is part of the moon's shadow where the entire sun is blocked by the moon. In space, it's a cone extending some 400,000 kilometers behind the moon. It's when the small end of this cone hits the Earth that we experience a total solar eclipse. Most eclipse maps depicting the path will show you a circle representing the shadow of the moon. But in actuality, the true shape of the umbra is more like an irregular polygon with slightly curved edges. This is because the moon isn't a perfect circle. It has mountains and valleys on its surface, which all affect the passing sunlight and subsequent shape of its shadow. And scientists now have a greater understanding of the shape of the moon's surface, thanks to NASA's Lunar Reconnaissance Orbiter. The unprecedented level of detail from the topographic maps, photos, and other datasets has allowed us to more precisely pinpoint the regions on Earth falling within the path of totality of a solar eclipse. So, if you get the chance to witness a solar eclipse, always remember that our little moon plays a role that's quite large.
Get that smaller and close that there and there. It truly is an incredible thing trying to get this. And yeah, everything that I'm going to be showing you, gosh, this will go down. Okay. Everything that I'm going to be showing you is going to be able to be another button and see if this will go. It will be shared with you. Not only will I be sure that my PowerPoint presentation is available to you, and in the PowerPoint presentation, I have included the link for any video that I have included. And I've also included a lot of speaker notes so that you can look back at these slides and gain a little bit more information. So excellent questions. It truly is amazing to be able to observe, as they were saying, not just one eclipse, but to have two eclipses that are going to be taking place. The next solar eclipse that we'll be able to see in the continental United States is not going to occur until 2044. So this is going to be absolutely a phenomenal opportunity. Another kind of an interesting thing is that the moon is slowly getting a little bit further from us and a little bit further from us. And in the future, and I'm afraid I don't right now remember how long that is, but in the future, we will not have these, we will only have annular eclipses, and I'll explain to you what that is in a sec here, versus total solar eclipses, because of the fact that the moon will no longer be the kind of same size as the sun. That is another truly amazing thing. And as master naturalists, you are not at all, I guess, surprised by the fact that nature has these incredible coincidences sometimes that we absolutely marvel at. And one of those right now is the fact that the moon and the sun both subtend, take up the same amount of space in the sky. It's about half of a degree. And so that is why when the alignment works just so, and it's that alignment that's pretty crazy as far as when we're actually on the day side of the Earth and the moon is in the direction where it's covering up the disk of the sun, it's really pretty crazy that happens. All right, now I'm going to show you another short video. And in this short video, it's going to explain the difference between this annular eclipse event that we are going to have happening, where what it basically is that the moon is going to be at its furthest distance from the sun, from the Earth. Because the moon also, as it goes around in its orbit is a little bit eccentric, and sometimes it's a bit closer to the Earth and sometimes a bit further away. During the annular eclipse, it will be a little bit further away than it normally is, and that's why it will only cover up about 90% of the sun. If you look at this poster, and there's some beautiful posters that are freely available at this NASA site, I'll be sure that I share that with you. This is one of them, and they all show just that little bit of light from behind the sun showing, which is one of the reasons why when I talk about safety, you never, ever, ever will take your glasses off during an annular eclipse, because the sun is mostly covered up, but only 90%. And you don't even want to get that 10% of direct sun shining in your eyes. All right, we're going to watch another short video that explains better than I can, and with lots of cool images, what an annular eclipse actually is.
Roughly every year or two, somewhere in the world, the sun appears for a few moments as a ring of fire in the sky. This is called an annular solar eclipse. Annular comes from the Latin word annulus, which means ring. An annular solar eclipse occurs when a new moon passes directly in front of the sun but appears too small to cover it completely. But why is that? It's because the moon's orbit around Earth isn't a perfect circle, but rather an ellipse, or slightly oval-shaped. This causes the moon to move closer to us and then farther away during its month-long orbit. When the moon is at its closest point, called perigee, it appears slightly larger in our sky. When it's farthest from us, at apogee, it appears a little smaller. But we don't see an annular eclipse every month. That's because the moon's orbit is also slightly tilted in relation to Earth's orbit around the sun. This means during most months, the moon is either too high or too low to block the sun. So only when a new moon is at apogee and passes directly between Earth and the sun, do spectators on Earth get the rare opportunity to see the ring of fire in the sky. Unlike a total solar eclipse, when the moon completely covers the sun, during an annular eclipse, the sun never fully disappears. So if you're lucky enough to be in the path of an annular solar eclipse, make sure to wear your solar eclipse glasses or use other safe solar filters to witness this spectacular ring of fire in the sky. Roughly every year.
Wanted to share with you, I'm only going to go into this technology, this kind of these technological bits for a little bit longer. I figure as master naturalists, it's a good idea to go in and give you a lot of these details, knowing that if for those of you this information tastes like more, you might consider joining our program and being an eclipse educator with the Texas Master Naturalists, and you'll have access to all of this information and on and on and on. And I hope you also think about the fact that when you're communicating this information to others, as you listen to this story, think about who your audience is going to be. And of course, different audiences aren't going to need this level of sophistication. You don't want to scare them. On the other hand, if they're truly interested, this really is some neat information to share with them. So, of course, when we're talking about any kind of eclipse, we have these different phases. We've basically with our annular eclipse, and this is going to matter because if you're helping to collect some data, the eclipse, knowing phases is going to be helpful in just kind of knowing how long it's going to last and what kind of data you might be looking for. So we've got our first contact, and that's where this partial eclipse begins. And that actually, it takes a little amount of time for the sun to really be covered. So you're going to start to see this first phase of the partial eclipse, this first contact beginning. Then you see that second contact where what they call full annularity starts. We have these really cool things called Baily's beads, and they're basically where we're seeing the edges of the moon. As they were saying, the moon's topography changes, and the moon isn't an exact oval. So as there's different mountains and valleys and different parts of the moon's surface, parts of those are going to be shining through as that shadow moves across, and we're going to see these things. A guy named Bailey discovered them, so they're known as Baily's beads. Now, the maximum eclipse, that is only going to be taking a little, it will depend on where you're watching the eclipse from for how long that lasts. I know that's all in the map, and it's certainly one of those things, if you go to any of the eclipse sites and you put the location you're going to be observing from, it will tell you how long this entire process is going to take. So you've got your maximum eclipse, but at this point in time, as you see here, you're still leaving your glasses on because there's still that sunlight showing through. And then, as makes sense, we've got what's called that third contact. And contact, basically, we're just talking about when the shadow of the moon is making contact with the limb, the outside of the sun. So that first contact is where it just starts to move into the limb, is what we call the outside of the sun, and then moves its way across. And then we finally get our fourth contact, and here we have this partial eclipse, or this annular eclipse, ending. Now, what's really neat, and you're going to see when I tell you a little bit about the research that's being done, there hasn't been that much research that has been done on animals and flowers, and insects as well, in kind of observing them and getting a feel for how they change, how they modify their behavior based on what's going on. I wanted to show you, this is something, and now we're going to take a look at the research that NASA's doing. This is kind of cool. This is showing us, there's a satellite mission called SOHO. And with SOHO, what they do is they put this coronagraph, this just kind of plate in front of their camera, so that all they're seeing is the outside of the sun, or the sun's atmosphere. And they do this so that they can better understand what's happening with the solar atmosphere. So a solar eclipse allows us an opportunity to study that atmosphere, or corona, without having to just use a coronagraph, which is something that's used to just understand the sun, but not its impact on living things. So these are some of the different things to decipher the sun's structure, better understand the sun's corona, study solar wind, that is the particles that are coming off of the sun, and sometimes doing damage to things here on Earth. And then also, and this is kind of where you come into play, what is the impact of localized blocking of the sun's energy? And Krista is going to tell us a little bit about some of the ways in which you can use the Globe Observer app to learn a little more about that. I wanted to show this video up in the top right hand. So as you're looking at the picture over here on the left hand that I took during the 2017 total eclipse. So I just pulled out, this was actually with my iPhone that I took this picture. But what we see when we see this kind of activity out here in the sun's corona, could very well be this activity that you're seeing over here on the sun's surface. The surface of the sun is incredibly active. Right now, we're also in a sunspot maximum. So the sun is very active. It goes through these 11-year cycles. And what we're seeing here are where there are solar sunspots, and they're sending their energy up, and they're connecting magnetic loops in the spot, and they're creating what we call prominences. So pretty cool, this activity on the sun. And in the bottom right-hand picture, what I'm showing is that what happens is we have this solar wind, we have these coronal mass ejections. It heads toward Earth. Earth is right down here in the middle of this. And again, talking about the incredible patterns in nature, this kind of spider that we're looking at here is basically the magnetosphere. So this is what's happening when the energy and the solar wind particles, they're coming over and they're making contact with the Earth's atmosphere, and then the Earth is being shielded by our magnetic fields. So that's a whole another level of study, which is absolutely fascinating, and something referred to as space weather and the sun and so on and so forth. Really cool stuff if you are ever interested and want to look into it. So one of the things that scientists are studying during eclipses is to get a better understanding of how eclipses can change the way that radio waves are passing through in our ionosphere, which is one of the layers of our atmosphere. So getting a better understanding of that. During this upcoming annular eclipse, there are several different science experiments that are going to be done by NASA. I believe there are, at last when I had looked, there are 5 specific ones that are going to be looked at. And I'm going to share with you in a couple of minutes the link to this story map online textbook that I've been pulling together, where I have collated all of these different examples. So if it tastes like more, you want to learn more, get in there and play around with it. We also want to better understand this extreme ultraviolet light that we're always, putting on our sun lotion for to keep the UV rays off of us, trying to get a better understanding of how eclipses may interact with and modify that kind of light. So we've got a lot of different satellite technology and telescopes where we're going to be collecting some of that information. And then as we were learning about when we were watching some of those videos, the moon is also a pretty amazing place, and we can learn more about the topography of the moon. If you look over here in this top right-hand picture and you see those little, that little kind of blue line, it's showing us that when we have these eclipses occur, it's helping us to better define not only the topography, but also some of those changes in topography on the moon. So I just wanted to throw those in. And again, you can take some time if you're interested and do a deeper dive there. But now let's come a little closer to home. We have some citizen science efforts that are going to be shared with you. Kristen's going to tell you how you can use the NASA Globe Observer app and help to contribute to a database where we're trying to better understand, in this case, things like temperature and wind. But before we jump away, I want to tell you a little bit about what scientists have learned in the past about animals and insects and plants, and kind of suggest some things you might think about doing as Texas Master Naturalists during the eclipse. And certainly when you hear about the Soundscapes program, you'll get a better understanding of some of the tools you can use to do that. So the Eclipse Educators, that is a virtual volunteer program that I pitched for the Virtual Volunteer Fair. Right now we have 75 Texas Master Naturalists who are a part of it, and any of you are still welcome to join. It's basically folks who want to do a deeper dive into the eclipse on their own time. It's a volunteer effort that is virtual. We have a story map, which is kind of an online textbook that I add to every couple of weeks. And we also have a base camp where we share ideas. We have a place where people can say, hey, I'd like to work with you. And the overall goal is that we find ways to communicate about these 2 upcoming eclipses with members of your local community. So you choose your own adventure with it. That can be just letting the teachers at a school nearby know that this eclipse is happening and giving them a 1-pager where they can learn more, to going in and actually doing library programs and citizen and so on and so forth. Again, it's choose your own adventure. During the eclipses, you're going to help us better understand the impact of the reduced sunlight and heat on living things through soundscapes, through observations, and data collection using the Globe Observer tool. I did a little bit of research on what we have learned about animal behavior thus far during eclipses and found some really neat things. One thing is that there's not that much data that has been collected. So the data that you might collect and the observations that you'll be making, especially during the annular, because then you'll be ready and have learned certain things and have some more questions, and maybe even have a better opportunity to then figure out what you want to observe during the total eclipse that will occur then in April. So during the 2017 eclipse, researchers from a zoo in South Carolina noted these following changes. Now, this was a small sample. There were 17 animals they were looking at. In the study, it goes through and tells you how each of these different animals, their behaviors changed. Because these were zookeepers, they had ongoing ability to look at these animals and to know what their normal behavior patterns were. So they were able to watch and get a feel for how their behavior changed. Mostly they noticed a lot of anxiety. They noticed some nocturnal behavior. Really, really interesting study. And what they said at the end was that they really need more research. I thought this was also a really neat one. This is using soundscapes. So you're going to hear more about how to get involved with this program. And I started off by, there was someone who'd written, I shouldn't just say someone, I forget who the gentleman's name was, but it was being written in a study that in 1593, it had been mentioned that the birds got so excited that they fell from the sky. And then in 2017, Nielsen was doing some data using 143 Doppler radar stations, and they were using them in various national parks. And they noticed that during the zone of totality, so, when we get there from that second contact to a full eclipse, there was these really short bursts, and they weren't quite sure if they were birds or insects. And these were occurring within the Doppler radar. So that's why it wasn't exactly a direct observation, just trying to better, use some sort of data to get a sense of what's happening. And they weren't sure if the birds were like confused and just kind of like flying out to see kind of what was going on, or if they were insects. They're not sure. Be kind of neat to try to figure that out. The acoustic biologist with the National Park Service, who got audio files from 14 different parks during the 2017 eclipse. And basically what she found was humans are very noisy. And they only kind of tap the surface in trying to better understand how animals and insects are behaving. And then finally, iNaturalist did a project called Life Responds. I really could not find a write-up on that yet, but maybe I need to do a deeper dive. They had people focus on 30 minutes before, then once during the actual totality, and then 30 minutes after. It was very open-ended. And what they kind of found was that frogs called more, flowers closed up, and the cicadas stopped singing. So just some kind of neat food for thought. And I'm going to finish this section up by showing you a brief video, if this will work okay, from CNN that was talking a bit about the anticipated reactions of animals. And this was before that eclipse. Let's see if, okay, I think we can get that here. Give it a second here to load up.
The rhythm and motion of the natural world. Birds chirping, insects buzzing, spiders weaving, farm animals grazing. Together, a tapestry of flora and fauna. But then, a sudden disruption in the cosmos, a solar eclipse. As the moon blocks out the sun, the earth suddenly grows darker and cooler, and the animal kingdom reacts. According to researchers, birds stop singing and cower in their nests. They get quiet, but the bees get louder. A restless buzzing emanates from their hives as they quickly fly in and out. On the farm, chickens and cows return to the barn. They believe night has come early and anxiously seek the safety of shelters. For nocturnal animals, the eclipse is an alarm clock. Bats and owls become more alert and come out to feed. It lasts for just minutes, but then almost as quickly as it came, the eclipse passes and daylight returns. Confused and apprehensive creatures pierce the eerie quiet with an explosion of sound, welcoming the sun back to the sky.
So it's going to be a really, really important opportunity to have our master naturalists helping us out in better understanding what is going on during an eclipse, with especially as related to the animals. I know some of you are asking questions. I purposely turned off chat for right now to not totally distract me. I used to be able to multitask with the best of them, but I'm not as good at it anymore. But when other people are presenting, I will go through the chat, and if questions weren't answered, I will answer them. I'm just going to finish up with talking a little bit about eye safety. So as I've mentioned several times, and I'm sure you know now is really important, the sun is never completely blocked by the moon during an annular solar eclipse. So therefore, it's never safe to look directly at the sun without special eye protection. And that special eye protection does not include regular sunglasses. So this is the national standard. This would be the number that you would need to see on it. They need to meet the ISO 12312-2 international standard. You will, I will be sure to put the link in here that talks all about safety and NASA into the link here, so you'll be able to easily access that. But do be sure that when you are looking at the eclipse yourself, and that when you're talking to other people, that they know that they have to use these specialized glasses. And as far as how long the glasses last, I'm going to see if maybe Krista knows the answer to that, because I don't know kind of what the official answer is. I do want to say one more thing with these glasses, and that is, do encourage people also not to touch the lenses, because our hands have oils on them, and that won't render them unsafe. You don't have to throw each one away if you touch the lens, but to increase your safety, it is important to not touch the lenses as much as possible. I wanted to put this in because I want you to see some of the really creative things that have been done with children. So you see down here in the bottom right, having children take those glasses and then create a little something special with them. Not only is it a fun way to get kids involved, but it's a great way to ensure that they're not going to look, those glasses can sometimes be kind of big, on their little heads, and to make sure that they're going to stay on, during the entire eclipse. That's a really fun project, and we do have some directions for how to do that in one of the links that I'm going to share with you. Pinhole projectors are another wonderful way to observe the eclipse. You don't observe it directly because there's various types of pinhole projectors, easy to make your own, and you basically are letting the sun's light shine through these little holes that you have in your pinhole projector, and then you're looking down where you're seeing it projected on the ground or on whatever surface you put that on. That might be a fun thing for people to make if you have a big event while they are waiting. So these are some of those indoor methods. You can actually just hold out a colander, use something that has a pinhole in it. And as I say, I'll make sure that you have this information here on this page that tells you a little bit more about that. So I'm going to finish up by sharing with you this absolutely, someone I see saying that they don't see. I will hold on. I understand there's a bit of a lag. I am sorry. So I'll slow down here for a sec. And all right. Thank you, Kristen.
Fear not as well for those that are experiencing a little bit of a lag. I think that's because we have so many folks on with us. Dorian has shared her slides with us, and we'll make sure to get those posted to our website as well with all the links and videos.
Thank you so much. Marvelous. All right. The last thing I want to talk to you about is this is one of the most fabulous resources that I highly suggest you get a chance to take a look at. This QR code here will take you to it directly. It is done by the library system. It's called Solar Eclipses of 2023 and 2024, the North American Doubleheader. And it's by Star Library Network, and they got a lot of funding from NASA. And in here, they have all kinds of information about the eclipse and tips and tricks. But something that they talk about that I think are important for all of you to think about is that when we are going to have these eclipse events, you're going to have a lot of people going. It's going to be wonderful, but also surprising how many people are taking their time to go and attend these eclipses. So because of that, you want to think about and tell people, if you're communicating to them about the eclipse, to take into mind things like traffic congestion. Okay, I'm sorry about the QR code. I will go in and fix it, folks. Of course, it worked on my end when I did it, but I had to make it because there wasn't one that existed.
Uh-oh, we might have lost Dorian. If we've lost Dorian, I think she was wrapping up, and I know she's going to give us her the correct QR code. Kristen, I think I'm going to pass it over to you if you're all right.
Yeah, no, that's fine.
on in.
Yeah, it looks like, can you,
Yep, there you go. While you get loaded, I do want to answer a few questions. Don't worry, we're going to have all these slides and links and videos posted. We also have Master Naturalist branded correct ISO eclipse glasses that we will have at the Master Naturalist Conference in October to pass out to all attendees, plus extras that you'll be able to take home with you for the April 2024 event. So we're going to be really stylish all together with our Master Naturalist branded safety glasses. So take it away. Thank you.
Yeah, and just to reiterate, although I put it in the chat already, but yes, the glasses should be fine from 2017, and there's even an official NASA page that says that. But the important thing is to make sure that they aren't scratched or damaged in any way. So if you see any damage on them, then don't use them. But that's, yeah, make sure. But otherwise they should be fine. So I'm going to talk to you a little bit, kind of continuing from some of the good general information about eclipses that Dorian was talking about, and the reference, how you can specifically use the Globe Observer app and the Globe Eclipse tool in the Observer app to take observations. So my role is as deputy coordinator for Globe Observer, and Holly Cole, who's the coordinator, is on. She's been answering some questions in the chat, but and as I think I noted before, I'm based at Goddard Space Flight Center in Greenbelt, Maryland. So what we're talking about, although, this astronomical event that's super cool, really exciting to see, but what we're talking about is the earth science angle on that event. So specifically how you can study some of the atmospheric effects, changes in temperature, clouds, and wind on the when an eclipse happens, because the Earth is solar powered. What happens when the sun is blocked by the moon during the eclipse? How can we observe these processes? And these slides actually are already on the Globe Observer Eclipse website, and actually the toolkit for informal educators on our website. So all of these slides that I'm showing are actually already up on our website. So the basic idea is, again, observing how the eclipse changes the atmospheric conditions, and we're specifically focusing on clouds and air temperature at kind of the basic level, although there's certainly some more advanced things you can do to do more than just that. But at the very basic level, we're using the clouds tool, which is always available in the Globe Observer app, that you can do cloud type, cloud cover, all of those sorts of things, and then the adding temperature specifically for the eclipse. Temperature is always part of the GLOBE program for people who've gone through the full GLOBE training, but for somebody just opening up the app, it's not always available, but we open it up special for the eclipse. And I'll get into a little bit more detail about the air temperature and clouds observations a little bit later. And then the other thing that's sort of part of this is that we do want you to observe and report on land cover and photograph and describe the landscape and the surface conditions that may have an impact on those differences in atmospheric effects in varying locations. We didn't have that tool during the 2017 eclipse, so we're kind of excited to add this information and see if we can see differences in temperature reporting, for example, if you're in a parking lot versus an open field versus hopefully not in a deep forest, because that's not a great place to see the sky and see the eclipse, but still, so we're having you report sort of basics of where you're taking these observations. And I think the significant thing is that you are contributing to a long-standing citizen science database that can be used by scientists and students to study the effects of eclipses on the atmosphere. So in that left-hand picture, Dr. Brant Dodson from NASA Langley Research Center is talking at the American Geophysical Union. I think that was the maybe the 2018 AGU event, but talking about some of the research he did on the 2017 eclipse data. And then those 3 papers to the right are some students, just some pages, screenshots of student reports submitted for some of the past eclipses, 2017, but also 2019 and 2020 that were in South America. So, you know, it's really, it's interesting, hopefully, for you to take the observations yourself, but also contributes to this bigger data set. And we do really want that comparison data, not just from on the path, but also outside of the path. This is data from 2017. Oops. Started again. So you can see each of those points represents an observation taken by a citizen science observer using the Globe Observer app. And there's the eclipse shadow coming through. The pink are the highest temperatures. You'll see as the eclipse shadow comes through, you see those temperatures dropping as the eclipse shadow comes past, and then you see them start to warm up again. So we got, in 2017, we had about 10,000 observers give us about over 80,000 air temperature measurements and about 20,000 clouds observations. We're hoping we can maybe match that or exceed that with at least the 2024 total. So how does the app work? Now, one note, this is based, there we go. On the old version of the app. There may be some minor changes, but this is going to be the basics. And we've mocked up some of the big changes we know are coming, like the land cover. And there you can see a Globe teacher sent us their setup ready to go for the 2020 eclipse in Argentina. So it's all in the app, the app kind of guides you through the observations. So you can practice a few days ahead of time if you want to, but really the app guides you through how to do everything. And the idea is that you get a separate thermometer. We do want you to have a separate meteorological type thermometer, not something that you're using to check your kid's temperature if they've got a fever, but a thermometer designed for measuring air temperature. Various types are fine. Liquid filled, digital weather station. There's a lot of types will work, but not like a person thermometer. And then you do some setup. Tell us what type you have. A little bit of setup in terms of Celsius or Fahrenheit. All the data stored in Celsius, but you can display it in Fahrenheit if you want to. It'll show you your location. You can turn on reminders for measurements. And then this idea of taking that land cover observation to kind of set the stage for where you're collecting your data. Then the app will have, based on your location, the maximum eclipse at your location and the current time, so you can kind of see that time passing. You can get to more information about safety and introductory info and get back to that configuration page, and then also view your previously collected data. That's all available on the main data collection screen. For temperature, it's pretty simple. There will be a countdown reminder for when your next data collection is going to be, and you enter data now. You look at your thermometer. This, I think, this is the Android version. The app will look slightly different in iPhone, but it's basically the same thing. You select your temperature, and then it'll record your temperature. You can see, here's an example. You can go back and see your previous observations. And if you realize, oh, I entered 39 and it was only supposed to be 29 or whatever, you can fix your data or and edit your observations, and you can see the progression of data being collected there. Every now and again, oh, I know there's supposed to be there's supposed to be a little pop-up thing there that says take a cloud observation now, and I'm not sure why it's not doing that, but it will periodically pop up a reminder to take an observation of clouds. You can also take an observation of clouds anytime you notice something changing. So for temperature, we're talking every 10 minutes, maybe upping that to 5 as you get closer to the eclipse. For clouds, every half an hour, maybe every 15 minutes closer to the eclipse, or if you see something interesting changing. The clouds, pretty easy to observe, and you can actually practice this anytime. This is always available in the app. Tell us overall cloud cover, sky conditions, cloud types, cloud cover, and opacity by height, and then take photos, which there's, let me get this, it's just a little video showing you kind of match up the circles, and it'll take the photos in each direction. So doesn't take very long. You can do a few of those if you see anything interesting happening. And again, we always want cloud observations. The air temperature is just kind of the special thing for the eclipse. And as you collect your data, it will create a graph in the app. So this is an example. I think this one was maybe North Carolina. I don't remember. I should have it labeled where this particular one observation was taken. But it builds the graph. You can see at the top the temperature dropping and then increasing again. And then also the percentage cloud cover. All of the data about cloud type and stuff is recorded in the GLOBE database, but this display just shows the percentage cloud cover, so kind of the basic number. And then you can share your graph on social media if you want to. And so this is the Globe Observer website, observer.globe.gov/eclipse. That has this basic information about how to take observations, a resource library that has that poster that was on the very first page, as well as some other things. And then also so this is under the Do Globe Observer section. The LIDA program also has some additional resources like these presentation slides. So if you're talking to other groups about how to use Globe Eclipse, these presentation slides are available in various formats, a PDF, a PowerPoint, and a Google Slides. That's the Eclipse resource library that has some specific things, and then the toolkit. I guess, oh, I forgot I put slides in here for this to go through. So that's what the toolkit looks like, and it has these presentation slides on there. So some supplemental observing tips and some other things you might be interested in doing during the eclipse, in addition to those kind of basic clouds and air temperature and a site setup for the telling us about the land cover. And so some things to suggest. The time about every 10 minutes, that'll give you the nice curve. You'll get a nice number of measurements. And we hope that you would take it for after maximum eclipse as well, so that you get the temperature drop and then the increase again. So I know, there's the big event, there's the ring of fire or the corona, and then everybody wants to leave. If you can, stick around, take some more air temperature measurements so that you get that nice full curve of the graph. And again, if you can increase it closer to the half hour before and after totality, you'll get a little bit more fine-tuned data, and that can be helpful. But during the actual maximum eclipse, that point of totality, those few minutes, put down the phone, put down the thermometer, enjoy the experience. You'll still get the nice curve, even if you don't have it in those exact couple minutes of the eclipse. And actually, we found that the peak, the lowest temperature was actually slightly after the maximum eclipse point, is what we saw in the data for the most part last time. But yeah, make sure you keep taking observations after maximum eclipse so that you get that nice full curve. Choosing thermometers, again, make sure you have a separate thermometer. The weather app on your phone is pulling data from a weather station that could be some distance away, so you don't know exactly where that's coming from. We do want you to have a separate thermometer. You can see a couple different types, some really simple alcohol-filled ones, some basic data loggers, and other sorts of things. There's lots of types available. And Globe has a list of equipment suppliers on the website but basically many types will work. You want one that has an accuracy of plus or minus 5 degrees Celsius and has at least half a degree Celsius divisions for the liquid filled models, ideally. The best thing to have is an instrument box, but I recognize that, most people aren't going to have those nice, like louvered instrument boxes that allow like the ventilation and all that sort of thing. So at the very least, try to make sure you're taking your measurements in the shade, in the shadow, in the tree, somewhere in the shade, so that you're not getting the direct sunlight heating up that thermometer more than the air temperature around it. So that's kind of the important thing. You can calibrate your thermometer if you want to check and make sure that it is measuring accurately. So ice and water, more ice than water, put in the ice water bath and make sure it reads between plus or minus half a degree Celsius. So you can see that particular thermometer on the right-hand side actually has one internal probe and then one on the end of that wire. So it's checking the one on the wire. And it is, in fact, within plus or minus 0.5 degrees C. So so that one's good. Observations every 15 to 30 minutes, more if you see something interesting. The Eclipse tool will remind you of that. You can also add narrative comments if you notice anything interesting happening. You can add those as notes on the captions to your clouds photos if you see something interesting happening during the eclipse. And you can see there on the upper right is just a general clouds observation that actually happens to be my brother-in-law, and then the lower right is some students in Argentina observing the July 2019 eclipse. And then if you want to do a little bit more, you could also think about looking at wind changes. So there's a simple rod and a ribbon, a wind stick. This is developed by another NASA project, the AERON project, the Aerocats and Rovers Education Network. They do some interesting things with kites and observations on kites, but they also developed the idea of this wind stick. And that can visually show if the wind is increasing or decreasing or changing direction. Now, it's not a wind speed measurement exactly, but you can at least see some differences in things changing. So if you're interested in doing this, I'm still working on the exact instructions, so they're not on our website yet, but they will be. But the basic idea is you put your wind stick somewhere, and then you can take photos of it when in your clouds observations. Or again, if you see a change, take a cloud observation, include this in the down photo, and then you can actually see if go back and look and see if there are any changes in the wind speed or direction, depending on the angle. I think wind speed is going to be easier to tell, but you could look at direction. There is actually a way to build a wind direction instrument, sort of an official wind direction instrument from Globe that helps with that. And you may need to use the manual photo option, not that automated one, in order to get the wind stick fully in your down photo. We mentioned the land cover observations. That's kind of part of the initial setup so that we know what your site looks like, where you're taking observations. You can include your thermometer in the down photo. We can confirm whether you, whether you're including what type of thermometer you're using. And then good idea to download the app ahead of time. You don't need to have Wi-Fi or cellular signal to collect data, but you do need to have your account set up and logged in. You need an internet connection to connect to the database initially to set up your account. But then after that, if you're in a remote area, you can collect the observations and then send them later. And then you can practice cloud and land cover observations anytime. Those are available anytime. And the air temperature will be available closer to the eclipse. And we don't have that timing exact determined, but we'll let you know. We also have some other resources. If you want to, you can add the narrative comments to the clouds observations. And then we also have things like this eclipse journal that could be an organizer, especially if you have like younger kids that you want to observe with. This could be a way for them to make some observations kind of throughout the course of the eclipse, but in a more kind of a simpler way. And then I will say, although it's not part of this presentation, if you are interested in going through Globe training, there's actually a lot more, you can do with Globe if you want to go through a more full training, if you want to do relative humidity or barometric pressure or actual wind measurements, and get an anemometer or a weather station that has actual wind measurements. Like, so we kind of have a progression of the simpler things to the more elaborate things. And I'm hoping that you could see my slides eventually. I'm just noticing.
I apologize about that technical glitch. I think since we've got so many folks on, we've just got a little bit of a delay on the slides today. And I will say, Kristen, too, we have 4 chapters that have been participating with Globe programs for a few years now, and different types of the Globe programs. The Hill Country chapter has had a Globe at Night program, as have the Indian Trail and the Sabine Neches chapter, and then the Blue Stem chapter, I believe, had the Globe Citizen Science program. So variations of involvement from the Master Naturalists with the Globe program already, and what a great time to pick it up, like you said, get ready, test out using it during the October event, and then take it home with your chapters in the April event as well, and then continue to participate in that Globe event on a daily, weekly, monthly basis.
And we're working on more and more resources to have more activities and resources and things to available to share. And I'll also put in the chat those slides that I was sharing. Those exact slides are on that Eclipse Toolkit page. So if you couldn't see the slides, I know, Mary Pearl, you can add them to the Texas Master Naturalist page too, but they're already up on that website. So
No problem. I'm going to add everything to the TMN Tuesday page so that we've got it all in one spot. I appreciate everybody's patience with the technical issues. But we've got one more speaker that's going to talk about one more opportunity for community science involvement with the eclipse that's coming up. Dorian mentioned it earlier with the sound when she talked about the Soundscapes project. But this is going to be something that we're also going to be doing at the October event. Thank you so much, Kristen. I appreciate it. And before I give you the helm here, Trey, for all of our attendees, we are going to keep our speakers on. So if there's a little bit of time at the end, we'll have a Q&A after Trey wraps up here. But Trey's going to talk about the Soundscapes project that I'm most excited about, that we can actually put onto the property that we're going to in October, and then hopefully train some of our volunteers on how to use that equipment for the April event to take back home to their home chapter as well. So Trey, take it away and let us know about the Soundscapes project.
All right. Well, hoping that maybe some people can see the slides.
Thank you.
So my name is Trey Winter, and along with my co-founder, Mary Kay Severino, we created the ERISA Lab, or Advanced Research and Inclusion and STEAM Accessibility, STEAM being science, technology, engineering, arts, and math. And our whole goal is how can we bring science experiences, science knowledge, but mainly participating in the science to people who might not have thought that science could ever be something that they could actually be involved with. And one of the ways that we try to meet these goals is that we start our design process with people who are blind and low vision. Now, the products that we make aren't just for people who are blind and low vision, but we use this process called universal design of learning in order to make sure that everyone can use our products, or at least the greatest number of people possible. And then we start that design process with people who are blind and low vision, because I'm an astrophysicist. And if you want to talk about underrepresented groups in astrophysics, people who are blind and low vision are probably the most underrepresented group of all. So in this, I'm going to benefit from people actually giving you all of the basics of the eclipse and these things before. I'm going to do typically what I do the best or worst, depending on who you ask, which is just tell stories. And the story is going to be about the inspiration about the Eclipse Soundscapes program, and then just a quick overview of how it works, and then how you can actually participate in it. I can actually make my slides advance. All right, so as I said, along with my co-founder, Mary Kay Severino, we came up with the Eclipse Soundscapes project. This is a participatory science project, and as with all ERISA programs, it has a scientist involved, in this case myself, and an educator involved. As we are both joint PIs of the project, so we're trying to give both the education merit as equal weight to the science as well. And then we have a series of consultants like the National Center for Accessible Media and others to help us with the accessibility components. Now, if you notice, either in the backdrop that I've got here or in the slide, if you can actually see it, there is a cricket, and you see a cricket in shadow in front of the sun setting. And honestly, it was really these crickets that gave us the inspiration for this project. I worked with a person who is blind and has been blind since birth at the New York Public Library System. And NASA has been working to try to be more inclusive and accessible, and had created this new Braille and thermoform book. So it's basically, you can feel different things within the book. It's a raised print using a process called thermoform. And I was bringing it to her library to kind of show her how to use it and saying how many she needed when I was working with NASA. And she just flat asked me, it's like, well, what is an eclipse like? And I realized I did not have a great answer for her, because one, I had not experienced an eclipse myself up to that point. The first one that I experienced was in 2017. Also, two, everything I knew scientifically, everything I knew, all the information I knew, all the training I had, was all based on visual, not just language, but visual experiences as well. So I found it So I hesitated for a little bit, and how do I explain to somebody who's never seen their life what it might be like to experience an eclipse? And I remembered a story of a friend of mine who'd become an eclipse chaser a few years before, after he experienced his first eclipse, of standing in a field out in the middle of nowhere, no one around, when the eclipse hit that maximum point. So right after second contact, um, all of a sudden this quiet field just came alive with a chorus of crickets chirping. And he said there was like somebody flipped on the cricket switch. And then he got used to it. He had about 4 minutes of totality, and the crickets chirping in the background seemed like normal. And then what didn't seem normal is the second that it came out of totality, the eclipse came out of totality, or third contact, all of a sudden somebody switched that cricket switch off, right? And then he noticed it again because it was such a sudden and drastic change. And so that was the story I related to my colleague, and that was actually something that very much interested her. And it made me think of this might be a way that we can actually involve more people in an eclipse by not just describing it visually, but as this multi-sensory experience. And you've already heard people talking about that before. You saw a video about animals changing their behaviors. Also, too, temperature changes are important as well. So all these different things aren't just sight-based. Now, we do have tools and materials for people who are sighted as well. But again, we're trying to use all of the different senses so that you can actually experience these eclipses in a different way, and then do real and meaningful science with it as well. And that real and meaningful science is, how do we measure the impact of eclipses to life here on Earth? And one of the things that's interesting about this, there are several things. One is that as an astrophysicist by training, I know that things in space are, our position in the Milky Way, our position in the solar system, the Milky Way's position in the universe, all these things external to our little thin volume of atmosphere actually do affect us here on Earth. But it's usually not in a very direct way. Sometimes it's in a way that, takes millions or billions of years to notice. Sometimes it's things that you only notice if you're, in charge of satellites, and you need to know when there is a solar flare or something happening, because it might affect communications. But an eclipse actually draws a direct line that people can experience between something celestial actually impacting us here on the Earth. So that is something that I'm, from an education point of view, I'm very interested in expressing to people participating in our program. But also, too, there is real science behind this. In fact, we are basically not mimicking, but we are extending what I think is the first participatory science project. You might also hear it called citizen science. We're getting away, at least my group is getting away from using the term citizen when we talk about involving and engaging the public with doing science. We call it participatory science. So what we think, we found the first participatory science program that occurred in 1932 during that eclipse, where a naturalist named Wheeler just used newspapers to ask people to just journal how they experience animals changing during the eclipse. And then he published his results in 1935. These were not very overly scientific. There's a lot of observer bias, and there's a lot of differences in how things were recorded, so there was no real methodology to it. And we thought we could do a better job, and we're leveraging something called soundscapes ecology in order to be able to make a scientific determination of how animals change their behaviors by measuring the changes in the sounds that they make, or the soundscape of a location. And now this is all made possible because there are a lot of new tools available. And if you can see the slides, I'm showing a slide of a little electronic device in a plastic bag, essentially zip tied to a tree. So this device is called an AudioMoth. And my colleague, Dr. Megan McKenna, who was mentioned earlier, worked with us as part of the Eclipse Soundscapes project to record sounds in 18 sites in 14 different national parks during the 2017 eclipse. We've got all that data, and we've been using that data to test this program. But the equipment that Dr. McKenna used costs about $5,000 to $10,000 per unit. So to be able to put this into people's hands, into the general public's hands, we need to find another way. And if you cannot see, I'll stand right behind it. So if you cannot see the slide, I'm holding an audio moth. And this audio moth is essentially about a $90 piece of equipment that can actually take science grade audio observations. So it's not even the size of a deck of cards, and it's a little circuit board. And then on the back is room for 3 AA batteries. And its memory is a simple SD card. So one of these micro SD cards, like you might see in some cameras, and also use as SIM cards in some phones. All very low cost, so that we can actually put these into the hands of the public all along the eclipse. And instead of taking the 18 recordings that the National Park Service was able to do with great precision, we're hoping to get 450 kits all along the paths of both angularity and totality, and have a much larger recording data set of almost the same quality that the National Park Service was able to take in 2017, but over a larger range of habitats, larger range of weather conditions, and really build up a truly statistically significant sample of data for a very low cost. So that's the benefit that changes in technology bring. Again, these are amazing. They actually, so we're setting the recording sampling rate to be 48 hertz, which, if you know anything about Nyquist limits, that means that we'll actually be able to have recordings that with reliable data up to about 24 kilohertz, and that's well within the range of human hearing and just above and just below. But these little things, we might have a couple of people in very specific areas saying this all the way up to 384 kilohertz, which, if you know anything about ultrasound, that's in the realm where we could actually study how bats use echolocation. So these are remarkable devices, but they're not quite as precise as the National Park Service recordings. So we are using the National Park Service's very detailed recording, and then a more, but not quite as great, not quite as precise recording to try to work together to determine if there are any patterns in how animals, insects, birds, and even people respond to eclipses. So these are amazing devices, and I can't say enough about them. And what we're doing is we're sending out these kits, and I have an example kit here, but there's also one on the screen. There's a few other items in this, but it's just so simple. We send people a little audio moth with a recording number on it, and the numbers like which recorder you are, and then a Ziploc bag, or should I say a very sophisticated water repelling device. It's a Ziploc, and 3 zip ties. And we're basically asking people to go to a place where they think animals may be making sound, record the location of that place, and then set the recorder out 3 days before the eclipse, and then retrieve it 3 days after the eclipse. And then in another envelope with our address and postage, send us back not the recorder, but just the SD card with the data on it. So, because that's all we need. So this has several advantages. One is that you can also, when you leave these out, you don't have to actually do that much during the actual eclipse itself. So you're able to either observe the eclipse, be part of a watching party, participate in globe observer events as well. You can participate in all these other programs, because really this is just leave it out and then pick it up later. Also too, you get to keep the audio moth recorder. And what we're hoping to do is funnel people who participate in our program to other participatory science programs that measure things like bird migrations or noise pollution levels or other things that are going on. And they're already not only trained to take audio recordings, but they also have the device as well. We're working a lot with libraries as community leaders to do the same. And again, leaving them with these so that they can make it part of their library of things, so that they can lend it out to their patrons for whatever purpose that they want to. So, talking to the naturalists, there's lots of different ways that you can participate. And I've accidentally left citizen science in this slide, so I need to edit that. It should say participatory scientist. But you can either be a participating science yourself, so you can actually collect data and be part of feeding us more information. You can run Eclipse events. We have lots of materials where you can actually run Eclipse learning events with community groups in your area, or run what we're calling a citizen science club, or participatory science club now, of a group of people, and train them and set out these AudioMoth recorders in different places. So I'm going to run down each one of these in a little bit more detail. So we've got this role, we've got several roles in our program. The first is a field researcher role, and a field researcher is just somebody that goes to our website, says, hey, I'd like to have a kit. And if you're selected to have a kit, you do just as I said, you set it out 3 days before the eclipse and then retrieve it 3 days after. There's instructions on how to do a time calibration on the AudioMoth. There's also and let me go back and pull up. There's also 2 instructions on all of the accessible items that we've added to the AudioMoth, which I'm not sure if you can see here, but if you can see the image, we've added tactile elements called bump dots all along the AudioMoth, so that if you know somebody who is blind or low vision, they can actually use the AudioMoth and follow the instructions by using the tactile wayfinding clues that we put on the AudioMoth, and they can actually independently, without anybody's help, use and deploy an AudioMoth. Set it up, use it, calibrate it, and deploy. So you can be part of that. We don't guarantee that everybody who signs up is going to actually get an AudioMoth. We are trying to send these out to people who are going to be in about 80% of totality or greater. But if you don't get a kit from us, you can actually make your kit, and we have information on the website of where you can get these AudioMoths, how you can set them up, and also how you can make them accessible for people who are blind and low vision as well. So you can do all that on your own if you want to, and then just send us the data. Or we also have this other science role called an observer role. This is made for anybody to participate in, no matter how much of the eclipse you're experiencing, or whether you have an AudioMoth or not. And it's basically an observer. We train you in how to have a multi-sensory eclipse experience. So much like the Globe Observer's eclipse journal, it's basically, we ask you to observe how, what you hear, what you see, the temperature, more, not in a scientific way, but more just, does it feel like the temperature changed before the eclipse, during the maximum of the eclipse, and after the eclipse? And that's really important for us because, one, that's exactly what Wheeler did, right? No, liquid filled thermometers, digital thermometers. So that gives us a way to compare directly to the results from 1935, but also gives us interesting ways to compare the human experience to the more precise data that the Globe Observer is going to be collecting. And so we are partnering with Globe Observer, using their temperature data, adding it to our observations. We're going to add our observations to theirs and build up a more and more rich data set for all these different things. And it also just allows people to participate in something together and share their results. So you could be a field researcher, an observer, and then we also not only provide the kits, but we also have a lot of online accessible learning resources. All of these resources were developed by professional educators, including Mary Kay Severino, who is the co-founder, but other educators as well, with experience in not just making tools accessible, but also to working with people who speak English as a second language, and trying to make sure that everything meets education guidelines as well as inclusion guidelines as well. We will be making a lot of our materials available in Spanish. We're hoping all of them, They're not online yet. We're hoping to have all of that ready by the 2024 eclipse. So you can be a scientist and actually do this yourself. You can just run Eclipse learning events. So we will be hosting a series of events where we have subject matter experts or SMEs like myself talking about eclipses, talking about how these soundscapes are important. We also have a science advisory board that has soundscapes ecologists on it. Unfortunately, Dr. Megan McKenna just had to step away from the project due to her other projects, but we have one of her colleagues named William Ostrich, Dr. William Ostrich now working with us. So talking about how important soundscapes are and what you can learn from soundscapes as well as eclipses, and why this eclipse gives us a unique opportunity to study how impactful events affect wildlife within their habitats. And again, all of our online resources are free and designed by educators, so you can use those as well in your events, and you don't have to tell us about it. You can just use them however you want to. But if you want to, somebody speaking at your event over Zoom or like this, you can sign up for an Eclipse learning event, and myself or somebody else will schedule a time to give a talk. And then lastly, what we're hoping to do is work with community leaders, and we're working with libraries a lot with this, but we don't want to just limit it to libraries, because there are lots of different community groups that might be interested in participating in eclipse-based science. And we're really happy to be working with Mary Pearl and the Texas Master Naturalists. You'll already be part of a participatory science club. I can't believe how many times I did not change citizen to participatory. As Mary Pearl said, we'll be sending her a series of kits for your meeting to study the annular eclipse. The annular eclipse is basically our beta test. We will use its data, and its data is very important and will be scientifically valuable. But we're going to do our main deployment in the 2024 eclipse, which you're in Texas, you get both, yay you. And we're going to learn how much our systems work, how much they fail during this. But the idea is to send kits to somebody who will be a mentor and learn all about the process, and then help others set up kits in a variety of places. And one of the key things I really like about this is that we're not telling you where to set your kits. We're letting you and your community decide where the best place to set the kits up. Since we're sending out hopefully 450, maybe more if we get increased funding, but we're hoping that by having so many, we might collect things that we didn't expect to find, right? This kind of, instead of like, we're going to study one species of cricket and study them in depth, we're casting a very wide net. And the idea is that this will be an extremely valuable data set that can be mined by soundscape ecologists for years and years to come. Now, there's another role which I haven't included on here because we don't have the pages built yet, but that's also a data analyst role. And so after the eclipses, we're going to host all of this data. Everything is open, everything's public source. You'll be able to download any or all of the data, but we're going to create an accessible online system where, we've already got most of it designed. It's actually going through some beta tests now, but where people will be able to listen to about 45-second clips of the data before, during, after, and during the transition of the eclipse, and tag it. So add metadata or information about the data to it. So did you hear crickets? Did you hear a car horn? Did you hear running water? All of these different aspects that will help soundscapes ecologists actually find the data that they need to solve the scientific questions that they're interested in. And this is all part of, again, having people really doing the science. This is a valuable part of the science. We'll be sharing the results with our community and how the scientists are working with the data, but being able to go through and add that extra information to the data is extremely important, because that's something that computers, no matter what you hear about ChatGPT, FYI, it's kind of garbage. It's like autocorrect, but with an ego problem. But it still can't really define what a human being kind of instinctually can do with pattern recognition. It's getting close, but it's not there. and those models need to be trained. So having people actually go through this data is hugely important. And from the educational side, it also helps us educate the general public on how science is done and the importance of different aspects of the scientific process. All right, so since I'm the last, I put up the question slide. We've got a lot going on with this project. It is still being in process. Since we're trying to make it accessible as well as educational, we do tons of focus group reviews, and lots of different groups have to be able to interact with them. There's lots of competing needs. So the site is still being updated, and will probably continue to be updated until about September, when we're going to have the final plans for the annular eclipse locked into place. But if you want to sign up and receive updates, there's a QR code. And I did check it before I got on this, but I'm a little bit scared now. You can scan that QR code, take you to the main site. You can go to our Get Involved page, and we're also on social media, or you can just email us at info@eclipsesoundscapes.com. I see Mary Pearl coming on, which probably means that she's about to get the big hook and tell me I'm out of time. But
No, not at all. I was actually gonna to start some of that Q&A that we were talking about earlier. Or that you were mentioning earlier, but also wanted to drop in the chat a link for signing up for some of the Eclipse Soundscapes tools as well. Cool. So as part of the Master Naturalist event today, this team of speakers has put together an evaluation, and part of that evaluation is also setting up let me share my screen now. Is also setting up an opportunity to I'm sorry, I'm trying to do too many things and talk at the same time. It just does not work for my brain. But with this TMN Tuesday event today, our speakers, Dorian and Kristen and Trey and the team that are behind these speakers have put together this survey to see how you as Master Naturalists are going to engage in these events, picking up tools like the Globe and the Soundscapes tool, but then show interest for using some of these tools like that Soundscapes tool that Trey was talking about, and getting signed up to apply for use of those. Trey and his team, Mary Kay, are going to train Michelle and I on how to use one of those at the October event. Again, we talked about that earlier, but that way we can be those mentors to share how to use those tools for the April event with our Master Naturalists as well. So we're going to get to learn together and then train together in October and prepare for that event in April. So with that, I'm going to keep this slide up just a little bit longer so that folks can participate in this QR code and engagement. And again, this will be on the website afterwards as well. But we've got a little bit of time if y'all are willing to hang around for a little bit longer and answer some questions.
And just before we do questions, if there are any, what Trey's presentation reminded me of that we do have some of our resources already available in Spanish. So we have an Eclipse card that's bilingual, and then we have our atmosphere, like one pager that talks about some of the effects you might see in the atmosphere. That's available in English and Spanish, as well as in a low ink version. It has like one that's very what's the right term, like saturated ink, and is very beautiful. But if you're trying to print out a bunch of them, there's one that's a low ink version. And we do plan to translate the presentation that I showed into Spanish as well, but that is not done yet. So we are trying to make a lot of the resources available in both English and Spanish.
Great, perfect. And I appreciate the consideration for accessibility. That's something that our Master Naturalists have really been striving to incorporate into their programs across the state. We had a major focus on it in the last couple of years, and so having our folks be able to participate with these types of programs is great.
So I want to respond to one thing in the chat. Yes, actually, I know it's a grasshopper. I am so sorry. It's not a cricket. The story was about crickets.
You're too cute.
But this picture of the grasshopper is so good. I know that there's a different one. But yes, I'm not an engineer because I can't actually make things really work. I can just pontificate about big, huge galaxies and stars and stuff like that. I'm an astrophysicist. But yeah, the fact I knew that it wasn't just a bug, you know,
Props.
we
In
have a
true master naturalist fashion, of course
Yeah.
they're going to identify and correct that. I love it. Educate. They were educating with
they were,
you.
I was educated. I did know, but whenever I get into that rhythm of the talk, the story was about crickets. But yes, the logo is a beautiful grasshopper, and I was going to actually say the name, but I forgot from reading it from the chat. So.
Well,
And
great.
Keep
Well,
saying
let's
it,
see if
Arissa.
we've got
It's
some questions. Let me see if I can find some questions in the chat. I know that Holly and Teresa have been doing a great job answering a lot of the questions as well. I did see one earlier that mentioned the incorporation of other citizen science programs like iNaturalist and CocoRoss. How much data sharing are y'all seeing with these multitude of platforms for community science collections focused on these two events? And that's a question for everybody.
So I think it depends on which project. I mean, we don't have any necessarily direct data sharing with iNaturalist or anything like that, but for this project and others, I think they can kind of intertwine very well. So iNaturalist, for example, is very focused on species level observations, whereas Globe Observer, for example, Globe Observer land cover is kind of the big picture. So we know we've had people use Globe Observer to get kind of the broad view of what's around them, and then do iNaturalist for like the species level observations. So there's some ways while we're not necessarily like our databases don't talk to each other, the purposes can be kind of complementary, and a researcher could certainly then go and grab data from both of those databases. And I think CocoRoss is an interesting one, and it's kind of a long story with the GLOBE program. We do use but that's CocoRoss. I think I know their basic is precipitation, which GLOBE also has. We use kind of the same instrument, but there's some timing differences, and I'm not sure that we're really looking at things like precipitation for this particular event, but in kind of the broader scope of things, we definitely do talk to them periodically. We haven't quite managed to really mesh things the way we might like to, but definitely know some of the folks at CocoRoss. I don't know other specific ones. Yeah, and I think as Holly points out that, you know, there's the aspect of that all of this data is freely available. So if a researcher wants to try to compare data from different sources and can find one project that's collecting one type of data and another project that's collecting a different type of data, but in the same areas or in some other ways, there's some great possibilities for analysis on the other end, even if the projects didn't even know about each other to begin with. So I don't know, Trey, if you have any other thoughts.
No, I mean, we started working with Globe later. I've known Kristen for a long time, but well, not that long because neither of us are that old. But we started working a little bit more formally with Teresa Schwerin and some other, trying to align things. But basically, NASA has an open data policy, and for all participatory science like we do, it's all open source because you don't know where those connections are going to be important. So you need to be able to see everything. So our mandate at Arissa Lab for Eclipse Soundscapes is to put our data out in a way that anybody can access with limited data tags so that people can find the data that they need, not just the ones I was telling people about, but also the locations of where it was taken, time information, how it was taken, all of that information that you need to be able to use other data with it to compare it. And we are working with foundations to make sure that the data is available for a promised time of at least 10 years, but hopefully in perpetuity. And then also working with some NASA data centers too, so that it will be, up and available as long as there's a NASA. So there's a lot of what being open and data sharing means. You can have the best of intentions and not actually be able to provide somebody with usable data. So there's lots of different components that go into it. And that's where having scientists involved is actually really important. Like, how were these observations taken? Because how the observations were taken is really important in knowing how to calibrate it with other observations.
Yeah, absolutely. And that kind of leads into another question, Trey, about the calibration of AudioMoth data that comes out. There was a question earlier about how does it, and we're diving into some of the detail here, but how do you take out some of that human interference sound And the specific question is, how do you deconvolute the various sounds that that the audio moth might pick up of various species or human background noise?
Yeah, so that's a great question. There are multiple ways to do it. We are actually using some very simple methods for this. And for this project, we are far more funded to engage the public with the science and do a science thing than to go deep in the science. So we're hoping that people will use the data that we collect to go deeper and deeper, and that we'll win some follow-on grants to do actually more science with it. We're basically going to do a lot of work with essentially taking Fourier transforms. I don't know how familiar people are with that. If you do any audio data or any kind of analysis of waves of any type via light or any kind of repeating pattern. Basically, what Fourier transform lets you do is let you take out different frequencies of data and then analyze those frequencies separately. So, and some of the target species, like, you know, not a cricket here, a grasshopper, right? It's somewhat known what frequency ranges those species actually vocalize in. And so you can actually just snip out all of the data is good enough that you can snip out the data. And then what I did a lot in my research career was signal processing and stuff like that. So, you know, you can remove a lot of the background. But this is also why taking baseline data is extremely important. So that's why we're putting Gallium moths out for 2 days before and then collecting them 2 days after the eclipse for 5 days worth of data gathering, because we can get a lot of information about the background and then, you know, use that background to be able to, you know, lower some noise levels by subtracting out some things. But you know, this data is going to be a little bit, like I said, noisier than it would be using the equipment that the National Park Service had. They're just not as well calibrated. I am, as a scientist, I'm putting a lot of work and testing a lot of audio moths to see what the background noise is, you know, see how temperature affects the noise levels and these different things. But we're just hoping that the amount of data that we're collecting will help us do a statistical analysis and kind of beat the noise down.
Yeah, and like you said earlier, that your October event is really an opportunity for y'all to field test and
Right.
really kind of troubleshoot all of the processes and the data before the major April event. And Trey, remind us, if you will, the deadline that currently shows on your website is July 10th for applying for an audio moth. Has that been updated?
For the annular eclipse.
For the annular eclipse. That's for the October event.
Yeah, so that's for October. If anybody here wants one, let us know. But we've pretty much distributed about as many as we can at this point for the annular eclipse, and we will be sending some to the to your meeting in October as well. The website is due to be updated with more current information for how you can participate in the October, but that deadline won't be until 2024. So please reach out and tell us how you want to be involved and how you're interested, and we'll work with you. I will say that things are a little filled up. We're actually got more of a response for the annular than we anticipated, seeing that it's supposed to be a beta test. So depending on going for some, you know, additional funding so that maybe we can raise the number of kits to, you know, 600 or 700. Yeah, but we're kind of not sure about that aspect right now.
And the methodology for signing up for showing interest in engagement is that QR code and that link that's on the website, that's on the screen right now. Trey and Mary Kay have built in an opportunity for master naturalists to put their interest specifically in through this survey. So please make sure that y'all are filling that out. I had a question for you, Kristen, and I haven't seen any other questions come in, and y'all are handling questions in the chat. Great, but you mentioned the 2017 eclipse and previous eclipse to that. What is the long-term projection of this data over multiple eclipse events in the U.S.? So how do y'all connect that data with changing environments, with changing I'm thinking like urban heat effect areas. So if I take a 2017 reading here today, and then in 2023, we've got habitat development, urban growth, changes in the environment. How do you smooth out all of those rough edges to get a longer term study on that data? And that's a really deep question. Sorry.
Yeah, no, that is an interesting question. I think my short answer to that is I'm not sure this is the right data to use for that, because I think this is such a, as I think one of the videos that Dorian was showing talks about, that any particular place doesn't get an eclipse like very, very often, right? So between 2017 and 2024, I think Carbondale, Illinois was the place that got both. And then there are, of course, places in Texas that are getting the annular and the total, but I'm not sure that would be, I don't know that I'm not sure how helpful it would be to conflate the air temperature data during the eclipse and those environmental changes, just because I think there's too many other variables involved. However, looking at air temperature and surface temperature and changes in vegetation, but not during an eclipse, is definitely something that you could do with globe data, just not the eclipse. I think just not during I wouldn't do that during the eclipse. I would just do that as a measurement over time. And I know, for example, and this is a little bit smaller scale, there's an interesting write-up on the Globe website, and this has been a few years, I think, but there was a school, I want to say, in the Dominican Republic that did some measurements of surface temperature in their schoolyard and in other areas, and really saw how high those, and that was surface temperature, not air temperature. So they're using an infrared thermometer, but then tested some differences, some changes they could make in their schoolyard to reduce the temperature. And then actually it became an advocacy thing to other places around the city to reduce the temperatures. I think they tried some different colored paints and planted some vegetation and things like that. So I would say this is an interesting, that the eclipse is an interesting data point, but I think we have to recognize that you can't do everything with the eclipse data, but you could start to look at using other aspects of sort of similar data in the long term. And there is some data in the Globe database going back quite some time. I think the other thing that though is true a little bit about the Globe data is that it doesn't necessarily cover everywhere you want data from. So it's helpful in some respects, but there are also maybe other data sources that can better answer some of those urban heat island questions. For example, satellite data, which may not have the same detail level as the Globe data, but does give you a broader, like more of a picture. So I don't know if that totally answers your question.
Yeah, no, that's great. That's great. You're right. There's so much variability. And then as Teresa put in the chat, the next eclipse in the US specifically isn't until 2045. And where those cross paths may happen at that point is hard to connect the dots all the way across from year to year.
And I think, well, you would expect, I think you will see some effect, but there's also, weather is really complicated, right? Is that you could have a location that's getting an eclipse and you see the temperature drop, but then also there may be some factors with a cold front moving in or a warm front moving in and things like that, that it can be pretty complicated to look at. Or the total eclipse in July of 2019 was right at the end of the day. So it's like very near sunset in a lot of places. So how do you pull out from that data what's the eclipse and the blocking of the sun, and what's just it's sunset and it's getting cooler? So I think there are some things that you can answer with this data, and I think it's certainly worth collecting because it's an opportunity to get data from a lot of different individuals in a lot of different places. But it can't necessarily answer every question that we have.
Well, and as Dorian mentioned too, this is also a wonderful opportunity for our master naturalists, for our volunteers, and for the general public to engage in a scientific endeavor that is impacting them at a local level, that has this astronomical extremity to it, to be able to be a witness to something of this magnitude, and then to learn from it and to be an observer, be a scientist for the day, and enjoy that event. I do appreciate, Kristen, when you said don't forget to put your phone down at one point during the event as well.
Yeah, don't miss totality, because I would say I was in 2017, I was in Beatrice, Nebraska at Homestead National Monument, and I have to say, I love how cool it is that so many people were traveling for a scientific event. And I know my understanding is in Texas, you take your sports very seriously and things like that. But this is like a large group of people getting together for a science event.
Yes.
And like, that is pretty cool. So I think,
I
yeah.
completely agree. I think that to me is one of the things that is just so incredibly awe-inspiring. And it is a really nice way for us to be able to build people's, sometimes how people may have a bit of a flagging belief in science. And I actually had someone say to me, well, what if the eclipse doesn't happen? When I was telling people about the upcoming eclipse in Oregon. And it made me stop and think like, wow, that's a great question, because it really helps to help us be able to communicate this message, and also say the reason we know this is because of math and science. And then it happens, and it really does help to build that sense of awe, but also of, wow, so science really does work.
Absolutely.
And for the record, the eclipse will happen. We're like, we may not be able to answer every question with science, but we're pretty confident the eclipse is actually going to happen at the day and time.
Yeah.
We've
been doing that one for a while.
Yeah.
Well, thank you guys so much for all of your enthusiasm, for your shared resources, and for your engagement. We really appreciate it, and appreciate y'all allowing the Master Naturalist to have this resource to be able to share with their community, because that is the role of a Texas Master Naturalist, is to take the science of what is happening outside, and get other people excited about it, get the public engaged in it, and collect that data for our scientists, our researchers, and our agencies that make these changes and or make these policies, make these research opportunities possible. So thank you guys so very much. We really appreciate it. I'm going to get the recording posted later today, and all of the resources and slides posted as well. So thank you to all of our participants. We appreciate it, and we will see you on our next TMN Tuesday, and then if not, in October at our annual meeting, where we're going to get to watch one of these together. So thank you guys so much.
Thank you for the opportunity. This was great.
Yeah, thank you for organizing, Mary Pearl.
Yeah.